I want to distinguish two types of mycorrhizal fungi, and you'll see how this comes together. The Ecto Mycorrhizae, ECTO in the front, means that these are fungi that coat the roots almost like a glove, like fingers fitting into a tight glove. They sheath around the roots. And they don't actually penetrate the root cells, but they go into the root. The other grouping are what are known as Endo Mycorrhizae, and these are ENDO. These are the ones that form those arbuscules that actually penetrate into the root cell. So you need to know that to move on to how this works with the plants that we're growing. So Ecto Mycorrhizae affiliate with trees, both the hardwoods and the softwood trees. It's believed that fruit trees do not form this affiliation. But Ecto Mycorrhizae are basically working with those 3% of the plants that make up the forests and the woods of this world. There was work done in British Columbia by a soil biologist named Susan Simard. And one of the things she discovered is this concept of mother trees. So the mother tree, in a mature forest, the upper canopy is shading the ground underneath the trees. When trees drop their seed cones, they drop their, whatever form their seed comes in, and saplings grow on the forest floor. And from the perspective of sunshine, those saplings really shouldn't be getting enough carbon sugar to grow. But they do get the carbon sugars, and it's because the mother tree, through its root system, affiliated with the mycorrhizal fungi, those fungi move on to connect into the root system of the sapling, and the mother actually feeds, provides a photosynthesis service for those saplings until the canopy opens up. That's pretty cool. We're going to learn how Ecto Mycorrhizae can tap into bedrock to mine minerals. So when I first start talking about mineralization, I'll be talking about azomite clay and rock dust and things you can either resource locally or buy. But how cool is it that certain types of mycorrhizal fungi make rock, solid rock, available as soluble minerals again? And these are the types that do this. Ecto Mycorrhizae are also the ones that have the fruiting body, the mushrooms. So anyone who goes out and gathers chanterelles or morels or boletes, you're gathering a mycorrhizal fungus, and that's its fruiting body that forms this delicious gourmet treat. If I was an apple tree, I'll be a dwarf apple tree for now, and this was my canopy, my roots probably reach about 2.5 times further the diameter of what's represented by my drip line. And the roots in that soil volume, regardless of how deep we're thinking, that soil volume, roots access maybe 3% of that space directly. So the rhizosphere, the place where the bacteria gather, the place where soluble nutrients coming by means of diffusion or groundwater, there's not a lot of shopping that a tree can really do in that space. When it has an affiliation with just one species of mycorrhizal fungi, and now I'm talking about the arbuscule type, those hyphae, the mycelium of those fungi, reach a little bit further so that the tree, that one plant I'm talking about right now, can essentially access 100 times more soil volume to get its nutrients. That kind of makes sense. You know, it didn't have a very big shopping district. Now it's a little bit bigger. But it gets really, really fascinating when we go further with this idea. It isn't just one plant, and it isn't just one fungi. And fungi have the ability to anastomize. So for fruit growers, we can really understand that. Whenever we graft the bud of one tree to another rootstock, we know that everything from that point will now grow the new variety. Anastomize means grafting. A hyphae can fuse into another hyphae. So that, in part, means fungi of the same species are expanding their reach, their mycelial reach. Different fungi affiliate with different plants. Some plants can have multiple affiliations. Something like the Douglas fir has maybe 200 different species of fungi that we know that connect with that. That means that different fungal systems bring nutrients back to the tree. Some of those nutrients can flow out in an entirely new different fungal system. And so now we're now talking about what's known as the common mycorrhizal network. And this sounds like a nature talk right now, but this is what we want in our orchard. Because when we start to have plants that can trade nutrients, and those nutrients can carry on through another fungal network into other plants, we start to have the ability for nutrients to get balanced, to be spread around where they need to go.